class. So this is Lillian. I'm the math teacher working for AthenaEducation. Okay, so welcome. And
do you mind give a little bit introduce of yourself, your background, your teaching experience, let students or parents know.
So I've been taught high school math for a while, and I also working for AthenaEducation. So I help students through their one-to-one private tutoring class, small group tutoring, and also I prepare students, talented students apply for the IB or AP program.
Very good. So in your class, during the last few years with Athena or your teaching, many of students already got accepted by IB schools, right? IB program, right?
Yes, yes.
Okay, good news. That's good.
Okay, now let's talk about this course, I think.
Sure.
Okay, so students, there you see, this is the official textbook that we are going to use. So this is IB grade 7. So we're going to go through this book in the course. And so let me quickly show you the contents. So here you see all the chapters in blue. We have 24 hours for this course, and we'll do 23 chapters. So in this case, it's a very fast-paced course and condensed. So we're going to go through each chapter in about 1 hour. So this is what we're doing today. We're going to do chapter 1. So my requirements for you are to take notes. I expect you to bring a notebook and your stationaries with you and a calculator with you for this class. And every time when you take notes, you just write down. So today we're doing chapter 1, you write down the chapter number and then the example numbers. We're gonna go through some example questions today. All right, do not copy the question. We don't have that time to save some time. Once you enrolled in this class, you get an ebook, so don't worry. Okay, so again, notebook, and then take notes for chapter number and question numbers and how we solve it for sure, okay? All right, then let's get started. So chapter 1, whole numbers, those are the topics. So let's do them one by one. Number system. Number system. Now, can you guess, open your notebook and write down, we are doing chapter 1 and example 1. Okay, so whole numbers has a place value system, which means place value means the place or position of a digit in a number determines its value. So let's say this value, we write it down as 5378, but we read it 5,378. The position of the value 5, which is the 4th digit counting from the right, it tells you the value is in thousands. So we do 5,000, and then 300, the third one from the right. So we do 100, 7 the second, that's a 10th, so 70, and then 8 is for the ones. All right. Okay, so now let's write down example 1 and let's give this a try. 1A, write in numerical form, the number, this one. Okay, so 3,000, 1, 2, 3, 4. This is a 4-digit number. 3 is 4th from the right. 200, 2 is the 3rd one from the right. And 7, so we are missing the 10th, so we put a 0 for the 10. And then 7. 3,207. Okay. All right, example 1B, I'll get one student to answer the question. If I click ask to unmute, are you gonna see it so you know I'm asking you to solve the question?
Yeah, I think that's how that works.
Oh, okay, great. click on one student. Maybe Brian for 1B.
Where's 1B?
1B here. What number?
The part is blocking. I'll have to wait a while. What numbers represented by 6? 600.
600. Great. Yes. Thanks, Brian. Yep. So we are good here, depending on the place that we can tell its value. Great. Okay. So let's move on. Those are a bit straightforward questions. And now let's move on to example 2. So if it's 50,000, then we put 5 for the 5th place, counting from the right, 600 fourth from the right, and then 74. So we're missing the hundreds. So there are going to be a 0 for that place. So 2A is 5, 6, 0, 74. This is called simplest form, and then expanded form is the addition. Is the addition. So can I get someone tap their answer in the chat for 2B? Ethan's doing that. Okay, thanks, Ethan. Yeah, we'll Ethan, yeah, Ethan, you have the right answer. Okay, now let me share you. So this is the expanded form, all right? I believe those questions are so easy for you. So let's move on to the second topic, rounding numbers. We're doing so good so far. So we're gonna round numbers off to give us a better estimation. Sometimes we don't need much details. Yeah. So example 3, we need to round them off to either the nearest tenths or hundreds. For suffix, one significant figure, we read suffix in short. We round to a number of significant figures if we believe this number of digits are important. What does that mean? One suffix, we believe one digit is important. So I believe the first one is important. This means we are gonna round it to the nearest thousands. And then D to 2, so the first 2 are important, similar to the nearest thousands. Okay, all right. Now can I get you guys working on it, and later I'll ask someone to answer. All right, give it a try. Okay, Angela, can you read your answer to us?
Yes, so for the first one, I got 770. And then for the second one, I got 6,700. For the third one, I did 3,000. And then for the fourth one, I did 15,600.
Oh, A, B, C are all good. D to 2 significant, which means, okay, so which means the first 2 are important. So we wanted to round it to the thousands. I only need 2 digits. Then I'm gonna look at the third one, which is a 5, so we round it up. Okay, so the last one, D, is 16,000. Yeah, I see some of you having difficulty for the D. Please change it. I see E and Ethan has wrong answers also for D. Yeah, please correct it, okay? All right, good. Now let's move on. Let's move on. So after learning how to round numbers, now this is the purpose why we run it, because we want to do some estimation. So sometimes estimation, sometimes we don't need many details. When estimating, we usually round each number to one significant figure. So only the first digit, first one from the left, is important, and evaluate the result. We call this one figure approximation. So this is special method. I'll do example 4. Okay, I'm gonna run each one to one. Run this one to thousands. I run this one to the first one, which is hundreds. Okay, so I'm gonna look at the second, which is a 2. So I round it down. That's 7,000. Next one, that's a 9. So round it up 600, which gives me a 42. And then 1, 2, 3, 5 zeros after. Okay, so the answer approximate value for this one would be 4,200,000. Are we all good? Okay, let's move on. Okay, let's move on. Example 5. Okay, let me hide this. Example 5. Again, give it a try. One figure approximation, and I'll have someone answer my question. Hi, Johnny. Can you read me your entire equation and your final answer, please?
Okay. So 39 rounds. 39,000 pretty much rounds to 4,000, and then 79 rounds to 80. No, rounds to 100. So then
No, rounds to 80. Rounds to 80.
80, yeah.
Yes.
And
So
then
we run to the first.
It'd be
Okay, go ahead.
4,000 divided by 80, which is 500.
50.
50, sorry.
4,000 divided by 80, which is 50. Yeah, okay, thanks, Johnny. Yeah, so just explain a little bit. When we run to the first significant digits, so this is a 10th digit, so we're gonna round it to the 10th. So we round it to 80, not 100. Okay, so far so good. Okay, now let's do some exercises. Okay, so we're gonna solve number 1 question B and the number 3 question A. All right, I'll give you guys 2 minutes to solve this 2, just this 2. Okay, and I'll get someone to answer.
Yes.
Oh, hi, yeah, can you read your equation and answer to me? 1B.
So 1B is 4,600 times 20 equals 92,000.
So one figure approximation. So we round to one significant figures for the first number. You want to round it to thousands. Can I do it again?
Okay, that was 100,000.
So
5,000.
Yes, the first one round to 5,000. And then times
20 equals 100,000.
20. Yeah, that's right. And then it goes to 10,000. Okay. Yep, there we go. Okay, 3A.
For 3A, I rounded the 405 into 400.
Yes.
And there's 52 weeks in a year, so I rounded that to 50. And
Great.
the answer I got was 20,000.
20,000. Perfect. Yes.
That's 2,000.
2,000. 400 times 50. 20,000. Okay. All right. That's one figure approximation. And then D, we're gonna operate with numbers. So we're gonna do all the 4 operations: addition, subtraction, multiplication, division. Familiarize yourself with the terms. The results are sum, difference, product, and quotient. Okay, so we're just gonna practice how familiar we are with the terms. Okay, and some basic math calculation skills. No calculators for those questions. All right, so Samantha, do you finish?
Not yet.
Okay.
I can't see the questions.
Oh, okay. Sorry. I'm trying to hide the answers from you. Is the screen not sharing properly? Can I see it now, Samantha?
Oh, yeah.
Okay. Okay. I think Jerry finished this question, so I'll switch to Jerry.
The 6A?
Mm-hmm.
Oh, I got 569.
569. Great, yes. You also finished 6B, Jerry?
Yeah.
Okay, so what's your answer, please?
45.
45. Great. Yes. Okay, so I'll move on then. Hope you all got the right answer for this 1, 6. And then now let's find out some products. Those are easy. All right, so these are easy. 7 times 8, 56, and then 80 and 70 times 800, we just add zeros. The way to think about it is to factor 80 into 8 times 10. And then the 10 tells us we need to add 1 0 at the end. 70 times 800 is similar. We are just gonna factor it to 7 times 10, 8 times 100. And then the product of 10 and 100 is 1000. So it tells us we need to add 3 zeros after that. Yeah, I see right answers in the chat. Okay, good. Then let's move on to the next question. Okay, this one, before we solve it, let's observe the question. Do you notice a special pair of numbers will give you a special answer here? So let's say for the question A, I noticed there's a special pair that I love, which is 4 and 25. The product of 4 times 25 is 100. And this is multiplication. There's 3 factors, but multiplication is commutative, which means we can change the order, and associative. Ideally, you need to do from the left to right, but you can switch the order. So you can do 4, you can switch this too. So you can do a 4 times 25 first, which is, so equals to 4 times, which is a 100 times a 37, which gives us a 3,700. Okay. I think I saw Johnny raise up his hand. Johnny, you can just unmute and ask.
Oh, no, I didn't raise my hand up.
Oh, okay, no worries. And then for 8B, I want you to do it the same way. I want you to find out how much is that 8 times 125 first, and then we time the 17. All right. I'll get someone to answer this question. Jessica?
Yes.
Hi, Jessica, can you answer 8B?
8B. I don't know.
There's somebody else. I don't know. Wait a second. I don't know. Let's give this a try. I think there's a Daniel. Daniel, can you give this a try?
Can I give it a try?
Daniel, where's Daniel? Daniel, why?
Which question?
8B. No, okay. I'll get Sherry to answer. I think Sherry raised up her hand.
Which question? Please say it again.
Oh, example 8B. 7 times 8 times 125.
Okay. 4 times 37 times 25.
Oh no, 8B.
Oh, sorry. Hold on. Wait, someone is chatting. I can't really see it. Okay. Again, I can't see it because someone is chatting in the thing and I can't close it. Okay, there we go. 17 times 8, which equals to 136, and then times 125.
Let's pause a second here. So I know ideally we should do left to right, but as I mentioned, multiplication is commutative and associative. We can actually switch the order to make the work easier. If you notice, 8 times 125 is 1,000. That's way much easier for us. Can you, instead of solving the original question, you can do this. Okay, do you want to take over from here?
Okay, yes. So we can do 8 times 125 first, which is, so 40 we have, and then 2 times 8 is like, 16, and then 16 plus 4. It's 1,000 and
yes, 1,000 times 17.
Yeah, 1,000 times 17 equals 17,000.
Perfect. Thank you, Sherry.
Sorry, I came late. I didn't know.
Oh, okay, no worries. Okay. All right. Great, thank you guys. I'm just gonna show you the steps. Please do not miss steps. So I'm just gonna explain a bit. 8A, you can, the solution, switch the order of the two factors. 8B, it put a bracket here mentally in this guy's head. So we find out the product here and then we move on, okay? All right, both way works. Okay, and now let's practice example 9. I'm just gonna quickly show you how I want you to solve this. Because those are 2 digits, so we have to do long multiplication and long division, all right? So let's test how your long multiplication and long division goes. When you finish, you can just raise up your hand, I'll see it, and I'll unmute you, okay? So raise up your hand when you finish both.
Wait, which one? The example 9?
Yes, example 9. Oh, and I see Nathan chat with me. We are doing example 9 and we are finding the exact value. So we are not approximating. Okay. You need to do long multiplication and long division. And Kenneth, the same thing. I think Ethan finished this. Ethan, can you share your answer with us?
Sure. Do you want me to share 9A or 9B?
9A.
9A is 1,305.
Yes. 1,305.
Yes.
Yeah. Thanks. 9B, who finished this? Can you raise your hand? Nine B. Okay, Angela, there you go.
For number A, I got 1,305.
Mm-hmm.
And then for B, I got 24.
Very good. 24. Okay, I'll share the solution with you. Okay, so I'll pause at this screen for 1 minute. Check yourselves. Okay, especially the steps. The step is very important. Okay, now time's up. Let's move on. Okay, so then we're going to talk about the index, or we call it exponent notation. So when we write a product of identical numbers, identical means the same, we can use index notation. So let's say you can write 7 times 7 times 7 times 7. The 7 is the identical number. And then we can write it in a simple form, saying 7 to the power of 4. And 4 is the index, or the power, or the exponent. It has 3 names, but they mean the same thing. And the 7, the identical number, is the base number. When you see 7 to the 4th, you do 7 times 7 times 7 times 5, 7. So in total, there's 4, 7. All right? So we can use 3 as example. 3 here, we have 3 as the base. And we write it in the index form, 3 squared, so 2, 3 squared. 3 cubed, 3 to the 4th, 3 to the 5th. It depends on how many 3, identical 3s that you multiply. And here the natural numbers are the product, the results. Okay, to test if we understand this, let's try solve example 10. Okay. We just need to write it in index form. Okay, I'll get a student writing here on the sharing screen. I think you can do annotates here. Tristan, somebody's writing here. Okay, yeah, you can go give it a try. You can just go. Yes, okay, good. So far I see good answers. Okay, sorry, I'm gonna disable annotation for you guys because it's kind of get messy. But so far I see all the right answers. 2 to the 4th, and then times 3 to the 3 cubed. 2 to the 4th times 3 cubed. Okay, so far very good. How do I erase this? Okay. Yeah, thanks. All good. Now let's move on. So example 11. right as an entered number, we wanted to find out the product calculated. Okay, 30 seconds and I have someone to give me the final answer.
Oh, we have to give you the final answer?
Yeah, who's that?
Wait, do we have to give you the answer or how it's written?
Oh, I'll just choose one student to share the answer. So, so everybody write it on your notebook. We're doing example 11. Okay, and you do your calculation there. I just have someone to share the answer with the entire class. That's it. Yeah, when you finish, raise up your hand so I know you finish. Okay, Jennifer. Can you unmute? Okay, then I'll ask Angela.
I got 360.
Perfect. Very good. 360. So again, on your notebook, your writing is this is what you're gonna put on your notebook, okay? And every time when we finish one example question, you raise up your hand so I know you're done. And I'll choose one student to share the answer with the class. Okay, now let's move on. Oh, this is a calculator question. Do you have your calculator with you now? If not, we can skip this one. Just practice calculating skills. Okay, we'll skip this one because I don't know to have a calculator with you or not. So we'll skip this. Okay, most of the questions is calculator-free questions. Only if it says. Okay, only if it says in the questions. So let's see. All right. Okay, as we may notice, if the index is 2, we read it as 2 squared or 3 squared. If the index is 3, we read it as cubed. So like this one is cubed. For those values, we call them square numbers or cubic numbers. Square numbers, for example, 9 is a square number as it can be represented by 3 times 3. So 3 times 3 square showing. If we can use a square shape to represent. So there's 3 dots on each side, which means the side length is 3. So when we find the area, we do 3 times 3 equals to 9. This is the geometric form that we represent for squares. Okay. And cubic is similar. When we have a cubic shape here, we see 4 blocks for each length, side length. So when we look for the volume, this is 4 times 4 times 4, which is a 64. So a number to the power of 3 is called a cube. All right, we're just gonna skip this part because it's mainly just square and cube numbers. Okay, and this is our last topic, order of operations. And this is the most difficult one. Okay, so but this is also a very interesting part. So let's all work hard on this. Okay, order of operations. The general idea is we work from left to right, but when we do different operations, subtraction and division in one expression, we need to decide which one do we do first. Okay, so here's the basic rule. Here's the basic rule. We call it BEDMAS, B-E-D-M-A-S. B stands for bracket. E, exponents. D and M, division and multiplication. M and A, A and S, addition and subtraction. So we are gonna follow these rules, okay, to do our operation. We're gonna solve the bracket first. And we're gonna do the exponents. Step 3, all divisions and multiplications from left to right. But if you can apply commutative rule or associative rule, you can do it here for multiplications. And then the last, you do addition and subtractions. So 4 steps, okay? Bracket, exponents, division and multiplication, addition and subtraction. We call this BEDMAS. So I'm gonna go through example 13 with you, okay? So I'll write it here. Example 13. Bracket, B, no. Exponent, E, no. So, and then division and multiplication, yes, there's division and multiplication. So I'm gonna work on this part first. So it's gonna be 35 minus 10 divided by 2, which is 5. Times 5. And then we're gonna do the multiplication, which is 25. Okay, so now we only have addition and subtraction. We're gonna do it from the left to the right. So this is a 10 and then plus a 3, which is 13. Okay. Now let's go to 14. The only thing different is we have a bracket now. So we're gonna solve the bracket first. We're gonna work on this part first. So in the bracket, we're gonna do the BEDMAS again. So when we work on this expression, there's no B, there's no E, and then we do multiplication, and then we do subtraction, okay? Yeah, now I want you to write this on a notebook, and when you finish, raise up your hand.
Wait, can you tell me why?
Which question are you asking? 14? Who was asking? I can't get lost. Which student was asking? Tessa, was that you? Tessa, you asked me?
Nope.
No, not you. Who was asking?
But I do have one question.
Yeah.
Why are brackets always first?
Oh, okay. That's an artificial rule. So when we work on the expressions, we want everybody to have the same result. This is kind of how you communicate with all the other math people. So if I say I want you to work on this part first, I'm gonna give it a bracket, which means if I post this expression to everybody. Everybody's gonna solve it in the same order, so we all get the same result.
Okay, thank you.
Mhm. Okay, Jerry.
Yep.
Can you
So-
share your work step by step?
Okay, so first I multiplied the 3 in the brackets with the 6.
Mhm.
So I got 18
Good.
minus 4 equals 14.
Yes.
And then so the numbers in the bracket equal 14. So 2 times 14 equals 28 plus 7 equals 35. So the answer is 35.
Very good. Thank you. Yes, of course. So as I mentioned, I use a bracket to emphasize I wanted that value here first. So you solve the bracket first, you do a multiplication first, and then subtraction. Okay? And then for the next expression, same thing, you do multiplication first and then addition. 35. All right, now let's do another one for practice. Here, there we go, 2J. Again, write this down on a notebook. And when you finish, raise up your hand. So I have someone sharing. Yeah, 16. Yeah, I see most of you got it 16. Dana, Joe, Jennifer, Johnny, Des. Yeah, you all got it 16. Okay, good. So I do the bracket, which is 8 first, divide by 8, 1. Subtract it from 17, 16. Good. Okay, all right. Yeah, we're on time. There's 3 more. Example 15. There's 2 brackets. So the square bracket goes with the square bracket. The round bracket goes with the round bracket. When there's more than one pair of bracket, we do the innermost first. So we do 8 divided by 4 first. And that bracket gives us a 2. And then you solve the outer bracket, which is 13 divided by 2, which is 11. Yeah, 5 plus 11, 16 again. 2, 16 again. All right, good. Okay, thanks. Okay, now we go to example 16. All right, 16, we see a fraction bar. A fraction bar means grouping. So we're gonna solve the top group first, and then we're gonna solve the bottom group. Okay, so solve this and that one separately. And the end, you get one number on the top, one number at the bottom, and you're gonna do division. The top is the dividend, the bottom is the divisor. Okay, so solve this one. I'll give you 1 minute, and if you are done, raise up your hand.
Wait, are they on a fraction bar?
Yes, the horizontal line in the middle, fraction bar. Okay. So we're gonna work on the 2 brackets, both.
I answer.
On the top, 4 minus 2, that's a 2. At the bottom, 3 plus a 4, that's a 7. Okay. And then we're going to solve the top and the bottom separately. So the top is a 14. The bottom is a 2. Okay. And then eventually 14 divided by 2 is 7. Yeah, I see most of you sent me answer on the chat. Yeah, you are all correct. So, and then let's move on to our last question, example 17. So here we have the E exponent. Okay. So again, bracket first, 6 minus 2, 4. And then E exponent. So this is a 4 times a 4. Again, I want to do this first, so I'm going to put a bracket for this. I emphasize this is my first step. So it's going to be a 3 times a 16, which is 48. Yeah. Yeah, I see most of you get 48. Good, good. Okay. Okay, let me see. I think there's some examples that we can work on. Yeah, sure. Okay, we're gonna work on 2 more practice questions, and that's pretty much our class for today. So we are gonna do 6E and 6H. All right. So I didn't hear you. Can I say it again?
Can I explain one of them?
Sure, sure. Which one do you want to do?
E?
Okay, great.
Yeah. Okay. It says 3 times 4 plus 5 to the power of 2.
Mhm.
So according to BenMath, we have to do brackets first, but there is no brackets. So now we have to move on to the next one, which is exponents. And we have an exponent here, which is 5 to the power of 2. So 5 to the power of 2 basically equals 5 times 5, not 5 times 2. So 5 times 5 is 25. And now we move on to division, but there's no division. And then it's multiplication. So 3 times 4 is 12.
Mhm.
And then plus whatever we get with 5 to the power of 2, which is 25. And that gives us the answer of 37.
Perfect. Thank you very much. Oh, by the way, what's her name?
Sherry.
Sure. Okay, sure. Yes. Thanks, Sherry. Very good. Next one, Nathan. Can you share your answer step by step with the class?
So first you have to do the brackets, which is 5 minus 2,
Mhm.
which I got 3. And 3 times 3 equals 9. And 2 times 2 equals 4. And 9 minus 4 equals 5.
Perfect. Okay, thanks, Nathan. All right, guys, great. We made this in 1 hour. This is the entire chapter 1. Thanks, everybody. We did a great job. So,
Very good. Thank you, Teacher Lilian.
oh, thank you, Michael. I just would like to tell them the homework. Review set 1A and 1B. So